So once again, instead of pressing resume recording, I pressed finish recording. I made the silly mistake of ending my recording before I was done. I had to take a break because I had a class coming in on the computer. But now we're back on the back page, the backside of systems of linear equations. So page 102 is where I'm resuming. I'm sorry for the cutoff in the video. All right, so let's see here. Consider the system of equations shown below and answer the following questions based on the system. Okay, which variable will be easiest to eliminate and why? So let's see. I'm going to label these again just like we did before, 1, 2, and 3. So we kind of have a point of reference, if you will. All right, so taking a look at those, which would be easiest to eliminate? Because remember, we're going to use two sets of two equations to eliminate the same variable. All right? So hopefully you guys are thinking that y would be the easiest. Because if we look, here we just have y, or 1y. Here we have 4y. And here we have negative y. So right off the bat, we can add 1 and 3 together to eliminate y. So I'm going to start with those two. And I'm just rewriting equation 1, 4x plus y. 4x plus y, like I was saying, minus 3z equals negative 6. And then, like I said, I'm adding equation 3 because the y variables have opposite coefficients. One's positive 1, one's negative 1. So rewriting that third equation, 5x minus y minus 7z equals negative 19. Now we add these. 4x plus 5x is 9x. Positive y minus y is 0. Those y's are eliminated. And then negative 3z minus 7z is minus 10z. That is equal to negative 6 plus negative 19 is negative 25. All right, so just like this, I now have one equation with two variables, x and z. So now I need to use two different equations. So I either need to use 1 and 2 or 2 and 3 to eliminate y again. All right? I'm going to work with 2 and 3. And the reason is because the signs are already opposite here. So I only need to multiply by a positive constant. Okay, and that positive constant, I'm going to multiply this third equation by 4. So if I multiply this by 4, then that will give my y a negative 4 coefficient, and this equation has a positive 4 coefficient. All right, so I'm going to rewrite equation 2 down here. Just going to draw a squiggly line. Not to get confused, equation 2 is negative 2x plus 4y plus 2z equals 38. And then I'm going to rewrite this equation, but after multiplying it by 4. So 4 times 5x is 20x. 4 times negative y is minus 4y. 4 times negative 7z is negative 28z equals 4 times negative 19, which is negative 76. All right? So remember, I can multiply any of these equations by any number that I want as long as I make sure I'm multiplying each term in that equation by that number. So that includes each term with a variable and the constant on the other side. Okay, now that I have these set up nicely and lined up like that, I can add them together to get a third valid equation. So negative 2x plus 20x is 18x. 4y minus 4y is 0. So once again, that y is no longer. Then 2z minus 28z is minus 26z. That's equal to 38 minus 76, which is negative 38. All righty. So just like that, I now have two brand new equations and totally valid equations. I have two equations now that both have an x and a z, but no y's. And now I can work with those two equations to solve for one of the variables. All right, so I'm going to rewrite them here. 9x minus 10z equals negative 25. And then I have 18x minus 26z equals negative 38. Okay? And guys, again, I'm aware that there's a lot going on with these. Right? There's a lot of variables, a lot of numbers, a lot of pluses and minuses. You just really have to be careful. Take your time. Breathe throughout, and we'll get through it. We'll get through it successfully. Okay? Have faith in yourselves. So now I'm looking. I have 9x and 18x, negative 10z and negative 26z. I have to figure out what would be easiest to multiply one of these equations by so that my coefficient of one variable will be opposite. Okay, you can fool around with your calculator, maybe divide these and see if they come out evenly at all. Or we can recognize here that 9x, if we multiply that by negative 2, that will give me an opposite coefficient from my second equation. So I'm going to rewrite this one right underneath after multiplying it by negative 2. So I can still have them lined up. So negative 2 times 9x is negative 18x. Negative 2 times negative 10z is positive 20z. And that's equal to negative 2 times negative 25, which is 50. Okay, so I'm done with this equation now. I need to add these two together. And just like we wanted, now our x coefficients are opposites. 18x, negative 18x. So when I add these together, they are no longer. X has been eliminated. We have negative 26z plus 20z is negative 6z equals negative 38 plus 50, which is 12. Look at that. Now we have a one-step equation here. And just like that, the value of z is in our pockets. So we divide by negative 6, divide by negative 6. I get z equals negative 2. Bada bing, bada boom. We're 1/3 of the way to our solution. And once we have this first value here, we have one of our variables solved. We go back to either of our two new equations. Let's see, maybe I should number this one 4 and 5. All right, make sure, I think you guys can see that there. Okay, so I need to work with either equation 4 or 5. I'll plug in this value of z, and that will give me my value of x. Then I'll go back to either equation 1, 2, and 3 with my z and my x and solve for y. All right? So I'm going to take my equation number 4 here. 9x minus 10z equals negative 25. Let's see, I'm going to do this up here so I have room. 9x minus 10z, which I know is negative 2, equals negative 25. So 9x plus 20 equals negative 25. I subtract 20 from both sides. It gives me 9x equals negative 45, because negative 25 minus 20 is negative 45. Now my last step would be to divide by 9, which gives me x equals negative 5. Whoa. X equals negative 5. And bada bing, bada boom, we're 2/3 of the way to our solution. We've got our z and we've got our x. We just need that y. Let's get that y. Let's go. I'm going to use my equation number 1. Start with my very original, back to our roots. Let's see where I can do this. Off to the side here. Hope you guys can see this. Okay, I'm rewriting equation 1, but I'm going to substitute in for x and z. So I have 4 times x, which is negative 5, plus y, minus 3 times z, which is negative 2, and that equals negative 6. All right, so now I multiply these out. I get negative 20 plus y plus 6 equals negative 6. Now I combine these. Y minus 14 equals negative 6. And my last step to get y alone is adding 14. If I add 14 to both sides, I get y equals 8. Ocho. 1 before nueve. So I have x equals negative 5, y equals 8, and z equals negative 2. And we've solved a 3x3 system. Your second one, guys, not bad at all. Way to go. Way to stick it out. Okay, way to believe in the process. Trust this beautiful process. Okay, we've solved that system. And again, if you guys want to, please check your answers. Okay, again, these 3 values will satisfy each of these original equations. Okay, they will work out in each of those equations. And you can check that if you want to, or if you need to. All right? So again, guys, this is a tedious, lengthy process, but it can be done. With a little confidence, a little hard work, you'll get there. Okay? I realize now that this lesson has been 34 minutes already with the 2 videos, so I'm going to end this lesson here. But I am going to do exercise number 4 in a separate video with a template that I think could help you stay organized and keep this process tidy. Okay, but I can't make you watch that, but I would strongly suggest it. I would strongly recommend it if you feel like you need more practice and you're looking for something else to help you understand. Okay, so again, I'm going to end this video here, but there will be another video dedicated to exercise number 4 with that 3x3 systems template. So please check that out as well.